Today, we're going to be talking about groundwater. This is kind of one of those things in life where you don't really think about it until there's a problem with it. It just kind of goes unnoticed, um, and people utilize it on a daily basis. So many things we do rely on fresh water, whether it's drinking or bathing or cleaning or cooling. Tons of different businesses and industries and things that we use on a quite regular basis require fresh water. So, using groundwater is one way that you can get access to fresh water. So, what is groundwater? There's a common misconception that groundwater is like an underground river system. There's, you know, some of that misconception comes in from movies and things like that, where they'll show an image of someone digging underground and then they encounter this underground river, things like that. Features like that do exist, but when you're talking about groundwater, what you're really talking about is rock and soil and gravel acting almost like an underground sponge. So all the cracks and crevices and openings and gaps between those materials allow water to seep in. And then that water simply stays there until it is pumped out through the use of wells. So most of the area in central Wisconsin does access their fresh water through the groundwater system. And certainly us here in kind of the Wausau area, Weston area, also use the groundwater system. Now you might be wondering, well, what happens if you don't have groundwater? There are places in the world and even in our own state of Wisconsin that don't have ready access to groundwater. So then they are left with having to use surface water resources. So the difference there, you might think, well, why doesn't everyone use surface water? One, because there's not enough surface water to accommodate everyone. And two, one of the benefits of groundwater is you have this large kind of underground storage area for fresh water. And one of the best things that the groundwater system does as that water moves through these tiny little cracks and crevices and openings in the rock is it acts as kind of a natural filter, and it takes out some of the impurities, some of the waste products, and some of the pollutants from groundwater. Is it perfect? No. But it does quite a bit of the heavy lifting so that when you pump that water out, it's a lot cleaner than it would be than if you just pulled it from a lake or a reservoir or a river or something like that. So to kind of break down the groundwater system here and what that all looks like, we have this picture right over here. So the groundwater is kind of in this area here. This section here, impermeable rock, really there's quite a few materials that could be impermeable. Impermeable just means that water cannot go through it, cannot penetrate that layer. So once the groundwater reaches that layer, it simply stops and then it starts to pile up. And how much it piles up kind of depends on the environment at the surface level. Is this an area that gets a lot of rain, or is it a more dry, kind of arid environment? And that's going to determine how high or low the groundwater system remains. So the top, right here in this image, the top of where the groundwater reaches is known as the water table. That's a term you may have heard before. If the water table is high or low, that kind of indicates the relative health of the groundwater system. So Usually in springtime, that's when your water table is going to be the highest, mostly because of rain and snow melt kind of recharging in central Wisconsin, the groundwater system. And typically, your groundwater is going to be at its lowest levels in, I would say, like late summer, when we've gone through the summer, and typically it's drier, it's hotter, and that groundwater system is going to be a little bit lower than it is at other times of the year. That means the water table is lower as well. The problem with that is that usually private wells don't go as deep as either large agricultural wells or municipal or city wells do. And obviously, if that water table is below where the bottom of your well is, if it drops below that mark, then your your pump could run all day and not bring up any water. And obviously, that's a problem because of all the uses that people have for water on a pretty regular basis. So, what I have a picture of for you here is an aquifer map. And an aquifer is just a term to describe the underground holding area where groundwater is held. Remember, it's just kind of rock acting like a sponge. In the cracks, crevices, openings, water is just stored down there, and we call it an aquifer. So I have this aquifer map, and you kind of see we here in central Wisconsin, kind of in this area here, have a pretty ready supply of groundwater. But you can see there are areas in northern Wisconsin, through the central United States, certain parts of the Northeast, that don't have ready access to groundwater. And because of that, they are limited to surface water resources. So they're looking at things like lakes and reservoirs and rivers to get their fresh water to meet their needs. So, with that, we're going to slide on down here a little bit. To kind of recap, the city of Wausau, I guess I would kind of lump Weston in with that as well, uses municipal wells. So these are pretty big wells that go fairly deep into the ground to access the groundwater on a regular basis. They pull that water up and then they hold it in these kind of reservoirs, and then as people need it, they will open up their taps, and then that water will flow to their homes or businesses to use as needed. So if you do not live in or near the city, then you have to have your own private well. So the only difference there is typically those private wells are quite a bit smaller, just because it costs money. And the deeper you go and the bigger the well, the more money that's going to cost. So kind of a cost benefit thing going on there. And you might be thinking that, well, if I live far out in the country, I probably have fresher water. In some cases, that can be true. But the other thing to consider is that a lot of people around you are also pulling water from that same groundwater system. So it's not just your little area and the water that you're pulling from the ground, but people around you definitely have an impact on the health of that groundwater system as well. And that includes, how much water they're using. If they're using a lot, that can impact you, as well as contaminants and pollutants. If someone nearby isn't treating the groundwater system with the best care, and some things are going into the groundwater system, it's all the same system. It's all interconnected. So eventually, those pollutants can get into your system as well. And if no one's watching, which typically doesn't happen as often, at a private well, You're not checking that on a daily or a weekly basis. Whereas with the municipal well, normally they're checking that on a pretty regular basis. I believe in Wisconsin, a private well, you're supposed to check that at least once a year or get it tested once a year. But a lot can happen in between that 1 year check, and that's assuming that everyone is doing that 1 year check. So how do we use most of the fresh water in our system here? Well, a surprisingly large amount of water is used in agriculture. So growing crops, maintaining livestock, whether it's chickens, pigs, cows, that requires a whole lot of fresh water for all different things, not just drinking, but also cleaning and kind of irrigating, keeping things moving. Agriculture accounts for nearly 70% of freshwater use. And after that comes the municipal use. So that is just kind of your daily residential drinking, bathing, washing, flushing. Could be at home, could be businesses, schools. That uses about a quarter of the fresh water. And then, kind of surprisingly here, you would think industry would account for a little bit more. But industrial purposes only use right around 6% of the fresh water. So that could be for cooling purposes, cleaning, in some cases, using water as part of a chemical process, depending on what the business is doing. That only accounts for about 6% of fresh water. So then we have water pollution. And, that's one of the problems with groundwater is that anything you do affects other people around you and vice versa. Other people, if you're doing everything right, you're checking, you're keeping things clean, you're not, pouring, old household cleaners into the ground, you're recycling those or taking those to the proper disposal facilities. You could do everything right and you could still end up with tainted or polluted groundwater. So, agriculture, because they're using a lot of water, there's a lot of responsibility there as well. Anytime they apply fertilizers, pesticides, not maintaining livestock waste facilities, so those would be like manure ponds, those can all impact the groundwater. Industry, anytime they use chemicals or things leak. Thermal pollution is another one a lot of people forget about. If you're using water and not really doing anything with it other than using it to cool something, you can't just immediately pump that hot water back into the system or back into a river or reservoir, because that can have negative impacts on the ecosystem as well. If animals and plants are used to a certain temperature water, that water needs to be at or very near that same temperature when it's reintroduced. And then finally, municipal areas, you got to be careful what you're putting into the ground, because if it goes into the ground and soaks in, it's going to the same location that water supply is going into. And if too many people do that, or it's done too often, that can have really bad side effects and impact everyone that requires groundwater. And then if you live near the coast, different things can soak in to the ground as well. Talking about pollution, kind of wrapping up this idea, we have these two ideas: point source pollution and non-point source pollution. So the way I think about this is literally, if you could point or you could identify where the pollution or the contaminants are coming from, that's called a point source pollution. So if we find, say, a very specific chemical in the groundwater system, and that's causing people to get sick or problems with groundwater itself, and that chemical is used by a very specific industry, say like the paper making industry, Domtar. If there's a chemical that they use and really no other industry in the area uses that, we find that in our groundwater, we could point to that company and say, hey, you need to change what you're doing or work on containing this chemical or filtering it out better, because we're finding this in the groundwater and we know it belongs to you because it's very specific. A non-point source pollution is where you have pollution entering and you're either not sure where it's coming from, or it's coming from so many sources that you're not exactly sure, how to mitigate that, how to slow that that contaminant getting into the groundwater down. And that can be a whole different kind of problem, basically, because how do you stop that? If it's coming from multiple sources, how do you make sure everyone is following the rules? Or worse yet, if you're not sure where it's coming from, how do you figure that out? How do you solve that problem if you're not sure where to even, trace that back to? So point source solution, you could point to it, you can identify it, fairly straightforward. Just fix that one issue that you may have with just one business or industry. And then non-point source pollution, where there's multiple sources or you're not sure where the source really is. So to kind of wrap all this up, groundwater, very, very important, because if you don't have access to clean groundwater, where are you going to get your fresh water from? Certainly there are places in the world that use surface water, but then you kind of lose some of those natural filtering effects offered by groundwater. The ground isn't acting as your cleaner or your filter as that water soaks in, and then it's just up to people, which is kind of a time consuming and a costly process to clean and filter that water. One other issue that I want to end with here with groundwater is we're finding the more we learn about the groundwater system, we don't know everything there is to know. We are finding that in some cases it takes centuries or even more time than that to fully recharge a groundwater system. It was always thought that a good hard rain or a good spring season would recharge the groundwater system back to its kind of original amounts. And depending on the type and style of aquifer, that sometimes can be partially true. But in a lot of places in the world that have relied on groundwater to kind of build their communities, they're finding that groundwater replenishes much, much slower than we're currently using it at. So if you kind of do the math there, if you're using something quicker than it can be like resupplied or replenished, that means the clock is ticking and eventually you're going to run out. So taking care of your groundwater system, making sure people aren't wasting or using too much and not allowing everyone access is very, very important. And there's a lot of places in the world that they're already having to deal with shortages or inadequate access to fresh water for all people. So water is one of those things that living things need. It's not something that you can just get away with not having for a period of time. So very important issues that people are working on and dealing with around the world. But here in central Wisconsin, at least for now, we have pretty good access to groundwater.